All right, in this problem, we're going to talk about mapping a figure onto itself, or sometimes it's called carrying a figure onto itself. So when we map a figure onto itself, or when we carry a figure onto itself, we perform some type of transformation to the figure so that the pre-image and the image end up exactly on top of each other, so in the same spot. So here it says a square is shown. Then they give us a square graphed here on our coordinate plane, and it says select all of the transformations that carry the square onto itself. So again, when it says select all, that means there could be more than one correct answer. So we don't just want to find one correct answer and then stop. We need to go through and look at each of our choices one by one. Now this is kind of what I was talking about at the beginning of the video. We typically say mapping the figure onto itself in class. But here you can see that the state test question said it's going to carry the square onto itself. That means the same thing. It's two different ways of saying the same thing. So we want to perform some type of transformation to the figure so that the pre-image and the image end up in the exact same spot. All right, so now let's look at our choices. The first one is a reflection over the line x equals 3. Well, x equals a number is a vertical line, so if we draw in x equals 3, this green line here, remember, in order for this green line to be a line of reflection that maps the figure onto itself, it has to be a line of symmetry for the figure. And we can see right here that this green line, x equals 3, is not a line of symmetry for the figure. It does not cut the square exactly in half. So this first choice is out. Option 2 says a reflection over the line y equals negative x. So y equals negative x, remember that is a line. The slope is negative 1, and the y-intercept is 0, 0. So that looks like this. Now, when we look at this line, the green line that's graphed here, that is a line of symmetry for the square. It cuts the square exactly in half. So that transformation does map the figure onto itself. So this is one correct answer. Or we can also say it carries the figure onto itself. If we reflect that square over the line y equals negative x, the pre-image and the image end up in the exact same spot. The next choice says a 90-degree clockwise rotation about the origin. So remember, when we are rotating a figure, the minimum number of degrees we need to rotate a figure in order to map it onto itself. To find that minimum number of degrees, we take 360 and we divide it by the number of sides that the regular polygon has. And a square is a regular polygon because remember, in a regular polygon, all of the sides are congruent and all of the angles are congruent. So if we do 360 divided by 4, we get 90. 90 is the minimum number of degrees we would have to rotate this square about the origin in order to map it onto itself or carry it onto itself. So this is a correct answer. All right, these next two problems, we need to be a little bit careful when we're looking at them because we're not rotating about the origin in these problems. So the next one says a 360-degree clockwise rotation about the point -3, 3. So 360 degrees, we would think that that would automatically carry a figure onto itself. And typically it does, but we need to pay attention to the point that we're rotating about. So here the point is -3, 3, which is this blue point right here. That is a vertice of the square. So if you rotate 360 degrees about the center or about a vertice of a regular polygon, you will map the figure onto itself. So we can select this. That is a correct answer. But only because that -3, 3 is a vertice. If that point wasn't a vertice or the center, this would not be a correct answer. All right, and now we're going to look at a 180-degree clockwise rotation about the point 0, -3. So again, we need to look at where that point is. We need to make sure it's either the center or it's a vertice. So 0, -3, that is down here. So it's not a vertex of the square, it's not the center of the square, so this is not a correct answer. A 180-degree clockwise rotation about that point will not map the figure onto itself. So let me cross that one out. And now we have 3 correct answers here. So 3 of these transformations will carry the figure onto itself.